to talk to you about today is something called simulations. Simulations is a way to use random number tables or a random number generator to model some kind of situation in which you're interested about a particular probability or a particular event occurring. So, let me start with a pretty simple example. It's often the case that when people start a family, they say to themselves, well, I really want to have at least one boy and one girl amongst the kids that I'm going to have in my family. Some parents start off that way. So let's, or it might be the case, someone with the parents saying, I really want to definitely have a boy at some point. Once we get a boy, we can stop having kids. So you might ask this question, right? On average, how many children would a couple need to have to get at least one boy? Okay? So to answer that, we can do it with something called a simulation. So if we think about the random number tables that we used to do our SRSs and our stratified random samples when we started talking about sampling, we can use them again in a new way. So what I can do here is I can say I'm going to let an odd number equal a boy and an even number equal a girl. And then what I'll do is I'll start reading numbers off a random digit table. So let's take a look at this table here. What I'm going to do is I'm just going to start any particular line. I'll start right here in the table. And if we're this young couple having kids, here it is, right? 4. 4 is the first number I read. 4 is an even number. And according to my code, I guess, that would be a girl, right? So this family is going to decide to have another kid until they get a boy. Well, here's the second kid that they have. Second kid they have is a 7. 7's an odd number. That's a boy. This family would now stop because they got the boy that they wanted, right? And they had 2 children. So what I'm going to do here is keep track of the trials, okay? So there's a number of trials we're going to do. So this is going to be trial number 1. Trial number, I'll call this. And then I'll put number of children until first boy. So trial number 1, that family had 2 children before they got a boy. Now let's keep in mind what our goal is. Our goal is this. On average, how many children would a couple need to have in order to get at least one boy? So far, we've done one trial, and that couple needed to have 2 kids. So continuing on that line, here's the next family. The first kid they have is a boy because it's an odd number, right? And then we stop. So trial number 2. Here, trial number 2, it was one child until they got the boy. We're going to continue to proceed in this manner. So let's look again. Let's do a few more. All right. So the next family, an even number is a girl, an odd number is a boy. So that family had 2 kids before they had a boy. So trial number 3 was length 2. Let's keep going. This next family, here we go. They had a girl. They had a girl because 0 is even, and then 4 is even. They had another girl, and then they had a boy. So here we go. Here's a family that had to have 4 children before they had a boy. So trial number 4 was length 4. Let's do a few more trials and see what we end up with. Okay, so here's the next family. Even number is girl, girl, boy. So that's 3. This was 4, 2, 1, 2. So trial number 5 was 3. Okay, and let's do one more. All right, so the next family here, you can kind of see, and that's an 8. I kind of drew over it. So that's an 8 there. So that's a girl and then a boy. So that family had 2 children before they had a boy. It's either an 8 or a 3. I'm not sure. If it was an 8, then the 6th trial gave you 2 children until a boy. Unless it was a 3, I'm not sure. So I kind of crossed it out. All right. So that said, what we can do is we can stop at this point. Now, this is really not quite enough trials, but it's enough to get the idea. We've done 6 trials. Ideally, when you do simulations, you like to do like 20 or more if you have time. All right, what can we do now? We can answer our question. The question was, on average, how many children would a couple need to have in order to get at least one boy? Well, here's a bunch of couples, and here's how many children they had to have to get a boy. All I need to do is get the average of those numbers. So I'm going to add them all up and divide by 6. So 14 divided by 6, right? Which is, it goes in twice with 2 left over, so it's 2 1/3. So according to the simulation, it takes an average of 2 1/3 kids per family to guarantee that everybody has at least one boy. You might have had a hunch about that, about what you thought the average should be, right? If you were thinking maybe it should take 2 kids on average, you're probably right, okay? Now, you might say, how come this is 2 1/3? Remember, we only did 6 trials. So you really should do more trials, and then most likely this number will get closer and closer to 2 as the number of trials goes up. Okay, we could change the question a little bit. We could stick with this family, and we could talk about a family that said, okay, I'm definitely going to have 3 kids. And I might ask this question. What is the probability that in a family with 3 children, there is at least 1 boy? So it's important when you read these questions, you see the word probability, get ready, you're going to be giving a fraction as an answer, right? Not a number, not an average like we did in the previous problem. Okay, so this family is not like the other families we discussed. The other families were going to keep having children. Once they got a boy, they were going to stop. This family's not going to do that. This family is going to have 3 children, and we're saying what's the probability at least one of those kids is a boy? Okay? All right, so let's talk about how you could do this in your calculator if you wanted to. All right, so I'm going to, just before we get started, we're going to do the same thing again. We're going to let an odd number equal a boy, and an even number equal a girl. By the way, we should be clear, we are assuming that the probability of getting a boy or a girl is the same. It's a 1/2 probability. We'll go with that. All right, so how can we do this? Well, if we were going to use our random number table, what you would do is you'd pick some line number, and you'd read digits 3 at a time, like this. Because every group of 3 digits is a family with 3 children. And then count up amongst them how many of them had at least 1 boy, and then start to get a probability. Let me show you how you can do it in the calculator instead. Here's our calculator. So your calculator has a function that will generate random integers. If you press the math button over on the left of the calculator, you'll get this menu. You go over to the right to the thing that says PRB, which stands for probability. And number 5 is what we want, rand int. So just press number 5, or go down to the 5th thing. Okay. And here's how it works. You tell them the starting number that you want, and the lowest number that you'd like to get back as an answer, and the highest number you want back as an answer. So I'm going to say 0, 9. Oops, I forgot to press the 0. Hold on a second. 0, 0. Where's my 0 button not working? 0, 9. And if you hit close parentheses now and hit enter, the calculator will give you back 1 number. Okay? 1 number between 0 and 9. Okay? And it'll be an integer because we said rand int. All right, so what would this be? According to our code, that would be a boy, right? Odd numbers were boys. So this family had a boy first, hit enter again, they had another boy, hit enter again, they had another boy. So this family had 3 boys. Okay? So I'm going to just start to keep track of my results here. I had boy, boy, boy. Okay? So let's keep going. Let's go back to my calculator. And I could start over again. So if you want to hit clear, you can. Like sort of make sure there's no confusion. Hit enter. That's an odd number, so that's a boy. That's a girl. And that's a boy. So this was boy, girl, boy. So far, here we've looked at 2 families with 3 children, and both of them had at least 1 boy. So if we stopped right now, we'd say, oh, our probability is 1. It's always the case that a family of 3 has at least 1 boy. But you really should do more trials. Now, I'd like to speed this up. I'd like not to hit enter 3 times. It turns out you can. So let's press math again. Go to probability menu. Okay, go to number 5. We're going to type 0, 9, and then we're going to press comma 3. Close parentheses. Now 3 at the end means we're going to pick 3 random integers between 0 and 9. So this helps you speed things up quite a bit. Hit enter. So here's your family of 3. We have even, which is a girl, odd, which is a boy, odd, which is a boy. So this is girl, boy, boy. Okay? And we just keep going down the list. Let's see what we got now. So we have an even, girl, and then we have boy, boy. So girl, boy, boy. Okay? All right. Let's see what else we got. Let's hit enter one more time. We've got girl, boy, girl. All right. So what you could do now is you could stop at this point. We've done 1, 2, 3, 4, 5 trials. And what we'd say is our probability, I'll write it this way, probability P, at least 1 boy in a family of 3 is equal to 5 out of 5. Because 5 out of the 5 trials, all of them had at least 1 boy, which is 1. So according to this simulation, stopping at just 5 trials guaranteed me to say, hey, look, probability is going to be 1. This is going to happen. Now, like I've said earlier, that's not enough trials. So what if you had done more? So after 48 more trials, an additional 48 trials, 38 out of 48 had at least one boy, right? All right. So we would add that to the fraction we already had. Now I'm not adding fractions in the traditional sense here. We had 5 trials, 5 of which produced families with at least 1 boy. So we have 5 plus 38 successes out of 5 plus 48 trials. Okay? So that gives me my newest probability to be 42 out of 52. 43 out of 53. My bad. Hold on a minute. 43 out of 53. There we go. All right. So that's an estimate for the probability of a family having at least 1 boy after 53 trials. Okay. And we haven't talked yet about how to do this probability theoretically. We could, but that's how it works. So sometimes, if you watch sports and so forth, they'll talk about a basketball shooting percentage from the foul line, right? All right. So it's my understanding 85% would be a good foul line shooting percentage. So suppose you had a player that at the foul line made 85% of his or her shots, right? And then you wanted to simulate that person taking foul shots. And let's say we were asked this question. What is the probability that this player makes at least 4 out of 5 attempts? So So let's say we wanted to answer that question. We're going to send this person to the foul line, make them shoot 5 balls, and we're saying what's the probability they get at least 4 out of 5 of those shots in? Okay, we can do this using simulations. We just need to be careful about our number assignment. So here is a way to do it. Okay, I can say let the numbers 1 to 85 represent the shot goes in. Okay. Now, I've got to somehow get the 85% to be represented. So I'm picking 1 to 85 to be 85% out of 100. So I'm going to say that 86 to 100 is a miss. And if you think about that, if I'm going to randomly pick one of these numbers, I have an 85% chance of picking a number between 1 and 85 inclusive. And then I have a 15% chance of picking a number from 86 to 100 inclusive. So this is a way to model this person making shots. Now they have to make 5 shots. Okay? So we'll do this with the calculator. So we can go to our calculator here. We'll go to math. We'll go to randint, number 5. Okay? And I'm going to type 1, 100. And remember, this person's going to attempt 5 shots. I'm going to pick them in groups of 5 and see what happens. So here we go. We hit enter. All right, and let's see what happened. This person got a 94, which means they missed a shot, right? They got an 11, which means they got it in. They got a 1, they got it in. A 55 got it in, and an 86 they missed. This person actually was not a success. So in the first case, the first result was 3 out of 5. So if we want, we could continue to write it this way. We could say 3 out of 5, 4 out of 5, whatever we got. Or I could just make a column and just do something like this. I'm just going to say success and failure. Because all I'm interested in, did the person get at least 4 or not? That's what I really care about. Right? So that's what I would recommend. Let's just make a success, failure chart. So here we go. Success, failure. Let's get this person to, let's see what we can find out over the long term. Okay. So I'm just going to hit enter again. Actually, I should go back to my chart there. We had 1 failure so far. The person did not make 4 shots the first time. So here we go. We hit enter again. And what do we have? We have 98, 28, 28, 13, and 6. So there are 4 numbers between 1 and 85. This is considered a success, according to the question. So I'll add a success here. Okay? Let's keep going. Hit enter again. Here we go. We got 73, which is under 85. That ball went in. 2 went in. 43 went in. 31 went in. 98 did not. So this is still considered another success. The person got 4 out of 5 shots in. Okay, let's hit enter again. What do we have now? We have gets one in, misses, gets one in, misses. I'm sorry. Gets one in, and then misses at the end. So they missed 2 shots out of the 5, only got 3 in. That's considered a failure. Oh, let's make sure I'm reading that correctly. Hold on a minute. That's in also. Okay, my bad. That's in. This is actually a success. I was not correct. So let's go back and fix that. It happens. All right, so this actually is a little more promising for this player. All right, okay. Let's keep going. Let's hit enter again. 2 numbers in the 90s. Even I can't mess that up. That means the person did not succeed. They missed 2 out of the 5. Okay, so that's a failure. All right, so we would need to do many more trials. Let's see what happens if we do that. Okay, go ahead. 4 successes. So 4 more of these. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 1, 2. 1, 2, 3, 4. Okay, so 1, 2, 3, and then 1 here. 1, 2, 3, 4. 1, 2, 1, 2. 1, 2, 1, 2. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and 1. Go ahead. Okay. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and 1. Okay. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so now you've watched the simulation for quite a few numbers, and we can count up and see how we did, right? So what do we have here? We've got, looks like, well, right here, 68, okay? So I'm trusting one of my helpers here. 68 here, 13 here. So we can count up the total number of trials we did, right? So we did 81 trials in total, right? And there were 68 successes out of 81 trials. So the estimate for our probability, the probability at least 4 shots go in out of 5 is equal to 68 out of 81. So that is an estimate for the probability. And if we did more and more trials, we'd get closer and closer to whatever the theoretical probability is. So let's change the question a little bit to the following. Let's say, on average, how many shots will this person make until the first missed shot? So notice this is not a probability question. This is an average question. We're asking you to find how many shots this person is going to make on average until they miss their first shot. So this is a little bit different to model. Okay, we're going to stick with the way we had done it before. Yeah, right. We're going to stick the same thing. We say 1 to 85 is he makes it. And then 86 to 100 is a miss. All right, so let's go to our calculator. And if you think about it, in this particular example, we don't actually know how many shots this guy is going to do until he misses. So we can't do something like rand int 1, 100, 5. We don't know if he's going to make 5 shots. Maybe it's going to take 7 shots before he misses. Maybe he's going to miss right away. So in this case, we have to go to math, probability, number 5, and we'll just do 1, 100, close parenthesis, and that's it. And then we're going to hit enter. So the guy gets back a 5. That means he got the shot in. So he's going to shoot again. He got a 12. He got it in. So we're up to 2 shots now. Shoot again is a 70. It's still between 1 and 85. He got it in. That's 3 shots we're up to. Shoots again a 99. He missed on the 4th. So what we would say is our first trial, trial number 1, here it is, it was 4. This is the shots until first miss. Notice how I'm including the actual shot he missed on. The word until means I'm going to include it. Okay? So let's go to trial number 2. Let's start the story again. You can see it's going to take a little bit longer this time. So we clear here, start over, hit enter. He makes it. Makes it. That's 2 shots so far. That's 3 shots so far. Up and misses. So missed on the 4th again. So trial number 2 generates a 4. Trial number 3. Let's try it one more time here. I'll hit clear, start from scratch. Hit enter. Makes it. Makes it. Makes it. Makes it again. So that's the 4th shot we're on. Here comes the 5th and misses. So this trial is going to yield a 5. All right, so we got a 7, a 6, 5, a 4, a 10, a 3, a 1, Okay.
16.
16. Wow. That's incredibly unlucky. 3. Or really lucky, we'd say, in this case, because the guy made 16 in a row. 3. 9. 18. Wow. 18. 6. 8. 5. 9. 4. And 7. Okay, so let's keep this all on track. What these numbers represent are the number of shots until this particular person missed. So you can see there's some pretty outrageous numbers here. The 16 is 18. These are really big, like, streaks, right? When this guy stood up and got 18 in a row, the crowd was going crazy, all right? But you can see that doesn't happen very often. So now all we're going to do is take the average of all these numbers, and that would give us, on average, how many shots this person would make until they missed the first shot. So let's see what that number turns out to be. The average will equal, so it looks like an average of about 6.85. Okay? Okay. All right, so I think this is actually 6.52. All right, well, it's a Monday. What are you going to do?